October 25th. Every observatory on Earth saw at a shift no one could explain, 3 Atlas. The third interstellar object ever discovered had drifted more than 1 million kilometers off its predicted course. Then came the impossible. Data from JPL and the International Asteroid Warning Network confirmed it. The object was accelerating sideways 4 kilometers per second, with no visible source of thrust. Astronomers gave it a name, a delta V against gravity, a maneuver once thought possible only for machines. For the first time in history, the ILRBUN launched a round-the-clock campaign to watch a visitor from beyond the sun, searching to learn whether its motion was ruled by physics or by intent. From this moment on, discovery belongs to all of us. Prepare yourselves. What we uncover in today's episode may not only redraw the map of orbits, but also redefine the purpose hidden behind them. Under the quiet veil of interstellar space, something is moving faster than any world we've ever known. Its name is 3I Atlas, a fragment of frozen time crossing the solar frontier at nearly 58 kilometers per second, or about 130,000 miles every hour. If you stood on the edge of Earth's orbit and watched it pass, it would take less than 12 minutes for it to circle our planet, if only its path were bound at all. But it isn't. Its orbital eccentricity tears through the mathematics of motion itself, declaring one thing beyond doubt: this traveller does not belong to the Sun. We trace its path backward through the galaxy, a reverse thread through 9 billion years of stellar migration. Each gravitational field it brushed against left a whisper, a nudge, a scar, a faint signature of momentum gained. The thick disk of the Milky Way, where old stars drift like ancient embers, may have birthed it. A region where metals are scarce, hydrogen rules, and cosmic dust gathers from the earliest epochs. Now pause for a moment. Imagine you are standing beneath the dome of an observatory. The night is silent except for the mechanical breath of the Atlas telescope scanning the horizon. The light it captures has travelled tens of thousands of years, yet the object it reveals has travelled billions. You realise its origin is older than the Sun, perhaps older than the spiral arms we call home. It is not just visiting. It is returning from a time before time. If its material composition has survived across 10 billion winters of radiation, then within it lies a memory of physics untouched by stellar fire. Carbon, oxygen, nickel, frozen not in reaction but in preservation. A relic from a galaxy before ours, cooled into order. You might wonder, standing beneath those turning mirrors, whether this is the last survivor of a system long collapsed. Whether it carries within its metallic heart the dust of a vanished civilization, or merely the chemistry of an extinct sun. Either way, it glides in silence, indifferent to our astonishment. Perhaps that is the truest mystery the universe has been sending travelers for as long as there has been space to cross. And only now, in the short span of human awareness, do we finally notice one passing through our narrow field of light. And as its pale tail fades beyond Saturn's orbit, you can almost feel its distance, a million Earths between you and it. Yet still, in some unmeasurable way, it feels closer than ever. When astronomers traced 3I Atlas backward through space, the numbers did not point to the crowded plain of bright young stars, but to the dim, ancient region known as the thick disk of our galaxy, a realm of memory more than motion. It drifts there like a survivor from the universe's early metallurgy, forged before the Milky Way had settled into its elegant spiral form. If you could look from above the galactic plane, you would see the thin disk glowing like a silver ribbon, while the thick disk forms a diffuse halo around it. Atlas's trajectory cuts through at a steep, rebellious angle, not following the rotation, but slicing across it, like a scar left by an old wound. We speak of galaxies as if they were cities, but the thick disk is more like an archaeological site suspended in gravity, each star a shard from an era when the universe was still molten and raw. The metals here, the nickel, iron, and carbon, are primitive, older than the chemistry that built our sun. 3I Atlas carries the same spectral fingerprints. Its isotopic ratios whisper of a time when the universe was still writing its first rules. It may be a fragment ejected when its parent star collapsed, or when entire systems collided and scattered their remnants across interstellar space 10 billion years ago. Now picture yourself hovering high above the Milky Way, seeing the arms turn like vast rivers of starlight. One full rotation takes roughly 230 million years, the age of the dinosaurs, for a single galactic breath. Atlas has crossed those arms dozens of times, Each encounter left a trace, a faint gravitational tug, a whisper of acceleration. Those minute pushes accumulated over eons gave it its 58 kilometers of momentum, a speed earned through patience, not chaos. It is in a sense a moving record of galactic history written in motion instead of words. And now as our telescopes catch its pale signal, we are not simply observing a comet. We are witnessing the return of an ancestral fragment carrying in its frozen shell the memory of a time before stars like ours even burned. They call it a comet, but the word feels small for something that may have seen the birth of galaxies. If 3I Atlas truly came from the thick disk, then it has drifted through the void for nearly 10 billion years, older than the Sun, older than the architecture of the Milky Way itself. What we witness now is not just a celestial object, it is a sealed message, a time capsule of the early cosmos, arriving uninvited yet perfectly on time. Picture its long journey. For eons it floated in darkness colder than 3 kelvins, far beyond any starlight. Every atom of carbon, oxygen and nickel inside it remained frozen in the state they were when gravity first sculpted galaxies from chaos. If you could slice into its crust, you would find layers fine dust compressed by cosmic rays, traces of helium and xenon isotopes, tiny fossils of radiation. Each layer marks a century, a million years, a collision, a pause. It is history written in minerals instead of ink. Now imagine holding it in your hand. The material is older than Earth's oceans. The metals inside were forged in supernovae that no longer exist. When we look at its spectral signature through the James Webb Space Telescope, we are not just studying composition, we are decoding a story of endurance matter that refused to melt for 10 billion winters. Perhaps 3I Atlas is more than a visitor. Maybe every interstellar object is a kind of letter written by entropy addressed to consciousness. It does not seek to be understood. It only arrives letting us glimpse what permanence might mean in a universe made mostly of decay. It moves as if time itself were carrying a keepsake, something the cosmos wanted us to find, not to keep but to remember. From the frozen silence of its journey, 3I Atlas drifts closer to the warmth of our sun, and for the first time in 10 billion years its surface begins to speak. The language is light. The sentences are written in spectra. When the James Webb Space Telescope tilted its golden mirrors toward that faint dot near the ecliptic, the signal returned not as an image but as a hum, a sequence of wavelengths that shimmered with coded meaning. Each peak, each valley on the infrared graph was the voice of a molecule breaking its long sleep. Scientists called them lines, but they looked more like fingerprints left on starlight. And the fingerprints told a strange story. The first signature was clear, an overwhelming abundance of carbon dioxide, far stronger than expected. The spectral line for water vapor, the defining trait of every known comet, was barely visible. The ratio was almost 8:1, a chemical dissonance that should not exist. If this were a normal comet, sunlight would warm, the ice water would boil away and jets would burst like geysers. But Atlas refused that script. It released carbon dioxide instead, whispering through vacuum without recoil, as though its body had never known the touch of a star. You can almost imagine standing on that dark surface. The sunlight there is weak, colder than a winter moon. Under your feet, grains of dust tremble. Every vibration becomes a photon, every vibration a syllable. If you could hear infrared, it would sound like a heartbeat slowed to centuries, the pulse of carbon awakening after eons of silence. Through the JWST's NIR spec and MIRI instruments, scientists mapped these voices into color. There were traces of methane and cyanides, molecules that predate biology, the chemistry of potential. In them lies the same code that once seeded the first oceans of Earth. It is as if Atlas is not merely passing by, but reminding us of the moment when molecules first learned to combine. Perhaps that is the real meaning of these spectral whispers, that light itself remembers carrying in its faint vibrations the memory of how everything began and how somewhere in that long-forgotten silence we were already listening. The deeper the spectrographs reached the stranger, the voice of 3I Atlas became. Inside the thin halo of dust surrounding it, light began to split into sharper and sharper frequencies, revealing lines that no comet should own. Instead of the usual balance of iron and silicate dust, the readings leaned heavily toward nickel and complex carbon compounds, like cyanides, a ratio almost inverted from every solar-born object ever studied. It was as if the materials had been arranged by a chemistry that belonged to another era of the galaxy. In the laboratory of space, every element tells a story. Iron speaks of dying stars, nickel of supernova cores that cooled too quickly, cyanides of prebiotic potential. But the combination seen here defied all those categories. The Nicke-iron ratio was nearly 3:1, a configuration possible only if the object formed in an environment starved of oxygen, a place where metals condensed before the gas around them could oxidize. That means Atlas may have been born in the first generation of stellar systems, when galaxies were still rich in hydrogen and thin in air. Imagine holding a flake of that dust. It would glint like polished graphite metallic, but brittle, more ancient than any rock on Earth. If crushed, it might release faint traces of HCN gas, the same molecule that on our young planet once built the scaffolding of DNA. The chemistry of death and origin intertwined a paradox travelling at 58 km/s. You might wonder whether such material could form naturally, or if it bears the pattern of intention. Was it forged by accident in a collapsing nebula, or engineered layer by layer in some ancient machine orbiting a vanished star? The spectrum alone cannot answer. It only reflects what is there. Yet to the trained eye, those peaks and troughs on a wavelength chart look almost like signals, organized, rhythmic, precise. Perhaps the truth lies in between. The atoms are natural, but their symmetry are deliberate, like music that no longer remembers its composer. When light from our sun strikes those metallic grains, they shimmer green, the color of nickel oxide, the faint hue of chemistry remembering its own creation. It is not proof of artifice, only evidence that even matter, when old enough, begins to imitate design. It began as a faint shimmer, like the breath of something ancient stirring in the dark. When the telescopes turned toward 3I Atlas during its slow descent toward the sun, observers saw a haze gathering around it, not white, not silver, but green. At first, they dismissed it as a trick of reflection, sunlight bouncing from interstellar dust. Yet the longer they looked, the brighter it became. The color deepened until it glowed like a living flame suspended in emptiness. Comets sometimes glow green because of dicarbon molecules, two carbon atoms joined together reacting with ultraviolet light. That is the ordinary rule of celestial chemistry. But when the James Webb Space Telescope studied the object, the spectral line that should have revealed those molecules was missing. The graph was silent where the mark of dicarbon should have stood. That silence meant the glow had to come from something else entirely. Imagine you are close enough to see it yourself. The nucleus turns slowly below dark and metallic, its surface covered in frost made of frozen carbon dioxide and traces of nickel dust. The halo surrounding it pulses gently, a mist of green light, expanding and retreating like the rhythm of breathing. If you could hear light, it would sound like the low hum of an electric current passing through crystal. The color fills space, not blinding, but steady, as though the void itself had learned to dream. Scientists searched for explanations. Some suspected nickel compounds fluorescing under the sun's ultraviolet rays. Others suggested cyanide radicals, molecules made of carbon and nitrogen, reacting with charged particles from the solar wind. But the brightness lasted for 23 days, far longer than any reaction they could model. Perhaps it was coincidence, perhaps intention. Maybe sunlight was simply discovering a new way to speak through ancient dust. Or maybe the universe was reminding us that even matter remembers, and that sometimes memory chooses to shine. From the fading green shimmer, the silence of 3I Atlas deepened once again. The color had gone, but something else shifted its path through the solar system. The light no longer spoke the mystery. Now motion itself became the voice. Astronomers expected a simple trajectory, a graceful arc shaped by the pull of the sun. Yet when data from the Jet Propulsion Laboratory arrived, the numbers disagreed with the models. The object's new position was 15.4 arc minutes away from prediction, equal to more than 1.1 million kilometers of sideways drift. At that distance, the shift could fit nearly 10 Earths across. At first, they blamed the tools. A telescope misaligned a timing error and uncorrected offset. But after recalibration, the displacement remained. The comet had moved not by coincidence, but by intent or by something that mimicked it. The strangest part was that the change made no physical sense. Atlas was venting enormous streams of carbon dioxide gas visible as soft plumes curling from its nucleus. In normal physics, that exhaust would act like a small rocket altering its path. But the trajectory stayed unchanged, stable, as if the object refused to obey the push. It was as one researcher murmured, a rocket that didn't move. You can almost picture it, a body spewing invisible fire, yet motionless, perfectly balanced in the black. If it were merely a comet, its momentum should have shifted by measurable fractions of a meter per second. Instead, every calculation ended in contradiction. To resist such thrust, the object would need to weigh more than 33 billion tons denser than any known cometary nucleus. That figure belongs not to ice but to iron. So the theories multiplied. Maybe the plumes were symmetrical, cancelling one another. Maybe Atlas carried an internal structure that redirected its jets. Or maybe the thought whispered in late-night meetings it was using propulsion of a kind we could not yet recognize station-keeping, as satellites do, maintaining course with unseen precision. By November, the pattern was undeniable. The orbit held firm even as the emissions grew stronger. The universe had presented us with a paradox in motion, a body behaving like a rocket but anchored like a thought. The emerald glow had faded, but the silence it left behind felt heavier than before. Light no longer carried the mystery of 3i Atlas motion did. What it did next would make astronomers question the laws that tether every planet and star. By early October, data from the Jet Propulsion Laboratory's orbital model began to drift from reality. The predicted position of Atlas and its actual track no longer matched. The gap was small on paper, about 15.4 arc minutes, yet in physical space that was more than 1.1 million kilometers. 10 Earths placed edge to edge. They checked the instruments again. The Atlas telescope, the Pan-STARRS array, even the Deep Space Network antennas all confirmed the same result. The object was leading its own predictions, sliding ahead of gravity itself. Here was the paradox. Every observation showed that Atlas was venting massive plumes of carbon dioxide, almost 8 times more gas than water vapor. That much outgassing should have acted like a rocket engine pushing the object off course. Instead, its motion remained steady, precise, undisturbed. The universe had built a rocket that didn't move. You can imagine standing near it now, the black nucleus turning slowly, whispering jets of gas into the sunlight. Each plume should twist its orbit ever so slightly, but the path holds true like an invisible hand correcting every nudge. For this to happen naturally, the object would need an impossible density, about 33 billion tons more like an asteroid forged of metal than a comet made of ice. Yet even that weight cannot explain the precision. Some whispered the word station keeping. Perhaps the venting wasn't chaotic. Perhaps it was a guidance system, a control mechanism built to hold course through the sun's gravity well. Whatever it is, the sky has grown uneasy. Equations that once described motion now describe defiance. And the question lingers suspended between data points. If Atlas isn't being pushed by the sun, then who or what is holding it still? The orbit held steady. The emerald light was gone, the carbon dioxide plumes had thinned, yet 3i Atlas traced the same immaculate line as if an unseen drafter were guiding its hand. If thrust was real, and motion did not yield, then weight had to carry the secret. Models from the Jet Propulsion Laboratory were pushed hard against the data. To keep the path unchanged while venting gas, Atlas would need a mass on the order of 33 billion metric tons. That is a mountain of metal adrift in sunlight, heavier than any comet nucleus we have measured, closer in spirit to a shard of planetary core than to a snowball of ice and dust. You can stand with us at the whiteboard and feel the numbers resist. Every equation bends toward the same conclusion: weight overrules wind. Now imagine the body up close. The surface is dark and granular, a frost of carbon dioxide clinging to metallic planes. Jets puff and fade like slow exhalations, but the trajectory does not tilt. If you placed a city-sized engine on a barge and fired it at sea, the water would push back. Here in the vacuum, nothing pushes back unless the hull is so massive, so dense in nickel and iron, that the exhaust is swallowed by inertia. That picture fits part of the riddle, but not the precision. Even a core fragment should wander a little when gas escapes. Yet non-gravitational acceleration, the tiny drift that betrays ordinary comets, refuses to appear. Which leaves a second possibility, the one mission planners whisper when the room grows quiet: station keeping. Not random venting, but timed releases. Not chaos, but control. Thrusts angled to cancel one another. Micro-corrections that keep the object on its chosen lane through the sun's gravity well. You and I can test the scale of it. A lateral push of only a few millimeters per second applied with care over weeks would steer hundreds of thousands of kilometers. Atlas moves at roughly 58 kilometers per second. A patient hand needs only tap the helm to keep it true. In control rooms from Mauna Kea to Madrid, simulations loop and loop, and the curves converge on the same feeling Atlas behaves as if it prefers this path. Preference is not proof, but it is a signal. If weight explains the silence, control explains the melody woven through it. The numbers no longer offered comfort. The orbit of 3i Atlas held like a frozen chord, too precise, too quiet. If its motion was not governed by chance, then something or someone was maintaining it. That thought carried through observatories like a cold wind. Soon the whisper reached the people whose task was to listen for danger. At the International Asteroid Warning Network, the alerts began as routine. Every object crossing the inner solar system is logged, measured, predicted. But this one felt different. The deviation reported by the Jet Propulsion Laboratory, the persistence of thrust without motion, the perfect retention of trajectory, none of it fit natural behavior. Within a week, the network moved Atlas from observation of interest to active planetary defense watch. It was the first time an interstellar object had ever earned that label. Imagine the scene in the darkened control room. Rows of screens glowing, blue eyes reflecting telemetry. Lines of code updating orbital elements, the sun at the center, Earth, a pale bead turning beside it. And there, a faint moving point, Atlas carving a line that refused to bend. If it was metal, it could be a fragment. If it was guided, it could be a craft. Either way, no one dared to say those words aloud. Reports flowed in from Mauna Kea, Cerro Paranal and Canary Islands observatories. Each confirmed the same brightness curve, the same steady, non-gravitational profile. The object's light curve even hinted at a slow rotation, as though Atlas was adjusting itself, minutely compensating for radiation pressure with deliberate ease. Then came a silence. For 3 nights, clouds and daylight erased all ground-based tracking. When signals returned, Atlas had shifted again, not wildly, not enough to alarm the public, but enough for the engineers to feel it in their stomachs. A course correction, subtle and clean, like something following instructions. Inside the network, the term station keeping escaped containment. It appeared in notes then in private briefings. The phrase meant controlled, deliberate stability, a hand on the helm of motion. To the scientists, it was an engineering term. To the governments reading their reports, it was a question of intent. You and I can almost feel it, the hush before a decision. In the dark above us, a silent traveller holds its course, with perfect grace, unshaken by heat distance or the pull of the sun. Whether that steadiness is design or destiny no longer matters. What matters is that we are watching, and whatever Atlas is, it knows we are. The night after the planetary defense alert, the skywatchers remained awake. The orbit of 3i Atlas had steadied into something like intent, and then, as if to mock the idea of calm, the object began to change shape. It sprouted a second tail, one that pointed the wrong way. Comets never behave like that. The solar wind always pushes their tails outward away from the sun's fierce breath. Yet this one, glowing in thin green light, began to form a beam of dust and gas facing directly toward the sun. It was so distinct that it seemed drawn with a ruler across space. Astronomers called it an anti-tail, but that name felt like a placeholder for disbelief. You can picture it if you close your eyes, 2 streams of light diverging from a single core. One trailing behind like the wake of a ship, and another pushing forward into the blinding gold, as if the comet were reversing the natural current. Dust grains no larger than pollen should have been blown away. Instead, they clustered toward the sun, as though pulled by a magnetic whisper we could not hear. The explanations came quickly. Some blamed the angle of observation, that we were seeing a sheet of particles from the side. Others said it was an illusion caused by geometry and sunlight, but the symmetry refused to fade. For 6 days, the second tail held steady, aligned to within a fraction of a degree. The Very Large Telescope in Chile measured its angle at exactly 181 degrees from the main tail, perfectly opposed to solar radiation pressure. Then, on the 7th night, spectrometers at Mauna Kea caught something stranger, still a jet of water vapor and carbon dioxide erupting toward the sun, not away from it. The temperature readings spiked. The coma brightened by nearly a factor of 2, then dimmed into silence. If that jet was natural, it was the most symmetrical coincidence ever recorded. If it wasn't, it was a maneuver. The term perihelion anomaly entered the logs. Some said Atlas was preparing for something, shedding weight, venting heat, resetting its orbit. Others whispered what no one wanted to write: maybe the jet was thrust. When Atlas finally slipped behind the sun, every telescope went blind. For 3 weeks there would be nothing to see, nothing to measure. Only the memory of a comet that pointed toward the light as if answering a call no one else could hear. When 3i Atlas vanished behind the sun, its light went dark, but its trajectory did not. Calculations showed that before disappearing it crossed the narrow orbital lane between Earth and Mars, a corridor that placed it within the sights of multiple orbiters. For planetary scientists, this was history offering a second chance. But what followed was not clarity. It was silence. On October 3rd, the Mars Reconnaissance Orbiter, the European Mars Express, and even the Emirates Hope probe were perfectly aligned to observe the passage. They each carried high-resolution instruments high-rise, capable of resolving objects as small as 3 meters, omega-tuned to capture chemical spectra. All three were commanded to watch. The data streams began and then stopped. No images were released, no spectra, no brightness curves. The only public photograph came from the surface, a Perseverance rover navcam frame showing a thin white streak above the horizon, time-stamped within the flyby window. The image quality was poor, a blurred trail across the dusty Martian sky. NASA called it an artifact of motion, a coincidence of timing. Yet the streak aligned perfectly with the calculated direction of Atlas's incoming vector. That alignment less than half a degree off was too neat to ignore. You can picture the tension in those control rooms, technicians scrolling through unprocessed image folders, communications bouncing between Pasadena, Darmstadt, and Dubai. Some screens went blank for calibration, others froze with incomplete telemetry. When the press inquiries came, the statements were brief data under review processing delay, no significant detection. And still, the high-rise archive, normally updated every few days, remained unchanged for weeks. Whispers began inside the community. If the data were truly empty, why the delay? The high-resolution imaging science experiment had captured faint meteor trails before even micro-impacts. Why not this? A few analysts proposed the simplest answer: the images did exist, but something in them required clearance. Perhaps a bright reflection, perhaps an object too geometric, too deliberate. By mid-October, independent astronomers had finished their cross-checks. The streak's light curve matched a solid, fast-moving object, not a transient, not a cosmic ray hit. It was real, and it was consistent. The only thing missing was context. So the Mars flyby passed into record as a mystery logged with a single blurred frame and too many explanations. The silence of space was not the only one that month. The cameras fell silent, radio telescopes began to listen. In science, absence of light rarely means absence of information. It simply means the message has shifted frequencies. What came next would not be seen but heard. As 3i Atlas slipped behind the solar corona, a cluster of observatories began recording faint oscillations in the microwave band. The Allen Telescope Array in California caught a narrow signal at 1420 MHz, the hydrogen line, the frequency of the universe itself. It lasted 11 seconds. Within that brief interval, the signal pulsed in intervals that matched a simple, unmistakable pattern: 2, 3, 5, 7, 11. Prime numbers. The data were rechecked by independent teams in Arecibo, Canberra, and Greenbank. Each reported the same structure. The transmissions did not repeat, did not modulate, and showed no Doppler drift, as though the source were holding position relative to the detectors. For every engineer, that was the strange part. Anything natural, pulsar reflection, plasma echo would drift. Atlas, it seemed, stayed still even in radio space. Skeptics called it coincidence. They pointed to interference from terrestrial satellites, to harmonics and calibration noise. But the waveform was too clean, the rise and fall too deliberate. It was as if someone had written mathematics into the dark. You can imagine the reaction. In the offices of the Galileo Project, Professor Avi Loeb convened a late-night call. The group had already been tracking interstellar objects, hunting for signs of artificial design. Now Atlas had given them one more puzzle. Loeb urged every radio facility on Earth to keep watch during the next solar window when the object would reappear. His memo was short: if the signal repeats, it is not noise. Yet when the sun released Atlas from its glare 3 weeks later, the instruments detected nothing. No light, no radio, no echo of the primes. Only silence, deliberate and complete, as if the transmission had ended exactly when it was meant to. And so the reports changed their language. The phenomenon was no longer called a detection, it was an opacity event. A veil. A moment when information existed then vanished by design. The world had heard something intelligent. Whether it came from a machine or from the silence that machines leave behind was now the question no one wanted to ask aloud. The signal had ended without echo. The prime numbers faded one by one until the spectrum went flat and 3i Atlas slipped behind the blazing limb of the sun. What followed was not silence, but a waiting so thick it felt alive, a kind of pause in which even light seemed to hold its breath. Astronomers called this stretch of time the blind window. Once every orbit, the sun claims the sky for itself, drowning everything behind it in radiation. Atlas entered that furnace on October 30th, and for the next 22 days it existed only as prediction, a string of coordinates without image, a theory suspended in glare. No telescope on Earth could reach it. Even the Solar and Heliospheric Observatory, designed to stare straight into the solar heart, found nothing but shifting plasma and dust. You can imagine that emptiness. Data streams flatlined, graphs turned white, and researchers began to study their own uncertainty. They compared the event to Comet Ison, which burned to vapor in 2013, and to Comet Lovejoy, which survived but returned as a fragment. Each comparison felt inadequate. Atlas had defied every model before. Why should it obey one now? Some teams simulated the physics of survival. If its surface was coated in volatile carbon dioxide, it should have boiled away, leaving a metallic core bright enough to reflect sunlight like a mirror. Others speculated that the intense radiation might trigger something deeper, that beneath the crust was machinery, waiting for an ignition threshold, a signal hidden in the rhythm of solar energy itself. What if perihelion was not destruction, but activation? It is a strange thing to wait for evidence that cannot yet exist. In that silence, imagination became the only telescope left. Every calculation, every absence began to look like intention. And so the phrase appeared in late reports, the activation hypothesis. If Atlas was natural, the sun would strip it bare. If it was not, the heat could be its key. The difference between melting and awakening depends only on purpose. Days passed. Instruments cooled in their housings, waiting for the sun to turn. Around the world, astronomers rehearsed what they would say if the object failed to return, and what they might say if it did. Somewhere beyond that blinding veil, a fragment of interstellar origin was enduring its trial by fire, and as the sun's orbit shifted, the telescopes prepared to reopen their eyes. The sun turned and the glare began to fade, the world exhaled. 22 days of blindness ended in a single frame, a faint dot emerging from the edge of the solar field. 3i Atlas had returned, but it was not the same. Its brightness was wrong. Before perihelion, Atlas shone with a predictable curve, steady cold dominated by carbon dioxide emissions. Now its magnitude was erratic, flickering in bursts that no model could smooth. Its coma, the vapor cloud that surrounds a cometary core, had grown thin, almost translucent, and for the first time it reflected light in a spectrum tinged not with green or blue, but a deep metallic gold. The change was subtle, but it suggested something radical, a surface transformation. Spectroscopic data from Las Cumbres Observatory revealed the surprise first. The usual absorption lines of carbon dioxide were gone, replaced by traces of nickel oxide and silicon carbide compounds that form only under extreme heat. It was as if the object's outer shell had melted and recrystallized into armor. Astronomers called it thermal annealing. Engineers might have called it a heat treatment. In conference rooms across the world, researchers debated the same impossible question: what happens when ice meets fire and doesn't die? A team from MIT proposed that Atlas had undergone a phase transition, turning its volatile surface into reflective metal. Another, led by the European Southern Observatory, noted that its albedo, its reflectivity, had doubled, yet its gas output had dropped nearly to zero. The object no longer behaved like a comet, it behaved like a vessel. Imagine standing on that surface for a moment. The sun fills half the sky, searing radiation washing over the hull. Temperatures near 2000 degrees Celsius cook the carbon away, yet beneath the furnace something holds together, dense, solid, unyielding. You might hear microquakes rippling through metal or gas jets whispering like controlled exhaust. The line between physics and design grows thin in such places. Then came the motion. Data from EAVN's renewed tracking network hinted that Atlas's trajectory had shifted slightly, just a fraction of a degree off its pre-solar path. It was a small deviation, no more than 1 million kilometers of lateral drift, but in orbital terms it was a whisper of intent. Natural forces could not explain it cleanly. No measurable jet, no obvious torque. Yet the numbers held Atlas had adjusted course. The announcement came quietly, hidden in the technical notes, post-perihelion positional discrepancy unresolved. It sounded harmless, bureaucratic, but to those watching it meant everything. Something had happened in the furnace of the sun. Some said the heat reshaped its orbit. Others whispered of an engine burn, a brief deliberate correction invisible in the glare. Either way, Atlas had crossed the solar threshold and survived, changed but whole. When 3I Atlas reappeared from the sun's glare, its light was steadier, colder, and unnervingly precise. The spectrographs caught reflections from a surface that seemed smoother than before, as if the object had been reforged rather than burned. But the true anomaly was not what it looked like it was where it was going. The Jet Propulsion Laboratory and the International Asteroid Warning Network compared their new orbital solutions. They did not match. The JPL model showed a clean outbound escape toward the outer solar system. The OWN data, however, traced a subtle inward drift, a deviation of just over 1 million kilometers from the original trajectory. At first, it looked like computational noise. Then, as more data arrived, the difference widened slowly, deliberately, like the tightening of an invisible arc. To correct its path by that much, Atlas would have needed a lateral push of nearly 4 kilometers per second. No natural process could explain it. The carbon dioxide jets had gone silent. No torque or mass loss was recorded. The acceleration seemed internal, as if the object had ignited something inside itself. A confidential memo circulated between observatories under a simple title, The Activation Hypothesis. It proposed that during perihelion, Atlas had stored a fraction of the sun's radiation in a latent system, magnetic, nuclear, or mechanical, and then released it as controlled thrust once it cleared the corona. In effect, it had used the sun as both shield and power source. The report outlined 3 scenarios: 1 spontaneous thermal venting, unlikely given the precision of the curve; 2 unknown physics, an exotic reaction of metal and radiation; 3 intentional maneuver consistent with station keeping or controlled navigation. It did not endorse any, but its tone betrayed unease. For the first time, the orbital vector crossed Earth's ecliptic plane. The numbers were clear: within 6 months, the object would pass through the zone shared by our planet and Mars. Statistically harmless, yet symbolically terrifying. It was coming closer, not farther. Inside the Planetary Defense Coordination Office, engineers debated in cautious language, monitoring campaign risk corridor. But in private chat threads, the question became simpler. What if it isn't drifting at all? Imagine something crossing 90 million miles of emptiness and adjusting its heading by design, a body older than the sun, using our star as fuel, now aligning with our orbit. Whether that change was coincidence or communication, no one could say. But across the world, every telescope was turned back toward the same patch of sky, waiting to see if the motion would continue. The term activation hypothesis began as rumor, a quiet phrase buried in late-night emails. But within weeks, it had become more than a model of motion. It had become a theory of change. The deeper astronomers studied 3I Atlas, the more its data looked less like a trajectory and more like a transformation curve. It was no longer accelerating. It was stabilizing, behaving as though it had entered a deliberate state. Spectrographs taken in mid-November revealed an unexpected chemical rebirth. Before perihelion, Atlas's spectrum was dominated by carbon dioxide, faint traces of frozen water and dust. After its return, that balance had vanished. Now scientists detected the fingerprints of heavy elements, nickel, silicon, phosphorus, and subtle emissions consistent with metallic oxides. But layered on top of those familiar lines were frequencies that matched no known molecule. The pattern was rhythmic, almost digital. To a physicist, it was interference. To an engineer, it was encoding. Some began to call Atlas a phase body matter, shifting through states as if its chemistry were being rewritten by light itself. The European Southern Observatory measured its reflectivity and found that it had fallen by half. Instead of scattering radiation like a comet, Atlas absorbed it. Its surface grew darker, less reflective, until even high-resolution instruments struggled to define its outline. For some, this meant degradation. For others, it was camouflage. Imagine standing near that object, watching sunlight soak into its skin instead of glancing off. The temperature climbs above 2000 degrees Celsius, yet there is no meltdown, no flare. Instead, energy disappears as if drawn inward, feeding a process we can only call reconfiguration. Matter rearranging itself for a new purpose. The analogy that circulated through observatories was simple, but unsettling: a chrysalis of metal. The sun had been its cocoon, the blinding fire its metamorphosis. What emerged afterward was not destruction, but intention. By late November, polarization readings confirmed it was reflecting light in 2 separate phases, one from a solid, core one from a faint ionized halo. It was in essence both object and field, a boundary blurred between machine and reaction. It's behaving like a material that thinks, one researcher said quietly. The IRB uncirculars described Atlas as quiescent. The classified memos used another word, active. Its orbit was steady, its spin synchronized, its emissions faint but coherent, too consistent for chaos. It had crossed the sun, endured the furnace, and emerged darker and more deliberate. The last recordings from the International Asteroid Warning Network showed 3I Atlas traveling cleanly along Earth's orbital plane. But when observatories compared their datasets, a small discrepancy appeared so small that at first no one noticed. The numbers didn't agree. The object's position against the star field was off by less than an arc-second, but the error persisted night after night. And in astronomy, persistence is meaning. The Minor Planet Center flagged it first. Positional variance exceeds model prediction by 0.8 arc-seconds. The note sounded harmless, a mere rounding error, but the follow-up data from Paranal Mauna Kea and the Roque de los Muchachos Observatory all showed the same drift repeating in a pattern: forward pause, correction, pause. It was rhythmic, almost biological, the kind of motion no comet, asteroid or debris fragment had ever shown. Astrometric analysis translated that flicker into distance, roughly 1 million kilometers of cumulative shift every 6 days. The path was still bound to the sun, still crossing the inner system, but the deviations traced a subtle spiral as though Atlas was slowly writing a new orbit inside the old one. Some called it precession, others noise. Yet when the raw coordinates were plotted over time, the oscillation formed a sine wave. Not random, structured. The term astrometric deviation was chosen carefully. It sounded scientific neutral, but those who studied it understood what it implied: control. No external force could explain the symmetry. Solar wind pressure would fluctuate. Outgassing would scatter the curve. Instrumental error would drift chaotically. This was different. It pulsed with a perfect period, 22 minutes, the same rhythm reported weeks earlier by radio astronomers who had heard faint bursts of patterned noise. The coincidence was mathematically impossible. Imagine standing beneath a clear winter sky watching a point of light that moves, not because of gravity, but because it chooses to. The motion so subtle you'd never see it with your eyes, yet precise enough to reveal intention to anyone watching closely. By mid-December, the deviation had become undeniable. The orbit was stable yet alive, a quiet breathing in the mathematics of the sky. The deviation was real. By mid-December, the models could no longer disguise it beneath rounding errors. 3I Atlas was drifting not away, not closer to the sun, but sideways across its predicted orbit. It was the most forbidden kind of motion in celestial mechanics: acceleration without cause. In the language of flight engineers, such a maneuver carries a name both elegant and impossible: delta V with a change in velocity. Atlas had achieved a delta V in the one direction the universe forbids, perpendicular to every known force acting on it. At first, the figure was almost invisible, a statistical shimmer. Then it grew solid. The updated solution from ION, cross-checked with JPL horizons, gave a lateral shift of nearly 4 kilometers per second. To the untrained ear, that sounds minor. To those who navigate the void, it's staggering. Moving a mass of 33 billion tons by even 1 kilometer per second would require energy rivaling a planetary detonation. Atlas performed 4 times that and left no trace of how. Computational models collapsed one by one. Solar radiation pressure too weak. Outgassing non-existent. Gravitational assist no nearby body to lend momentum. The correction appeared internal, a single pulse perfectly tuned. Some began to call it the impossible vector, a movement that broke Newton but obeyed intent. You can picture the scene in mission control rooms. Rows of monitors silent except for the hum of fans. Someone rewinds telemetry, another checks timestamps. Every recalculation leads back to the same answer: the orbit shifted not from push or pull, but from decision. A delta V without exhaust, without debris, without loss of mass. Motion as thought. To achieve that, naturally, Atlas would have to eject material at velocities exceeding 50 kilometers per second, no plume, no thermal signature, no fragment trail. Spectrographs showed serenity. Its coma was steady, its reflectivity unchanged. The object looked still even as it glided onto a new course. Some analysts suggested electromagnetic propulsion. Others whispered about directed energy or magnetic sails buried within its metallic skin. But those were only metaphors for something larger, a technology so efficient it hid inside the laws it broke. Imagine a massive ancient visitor, its surface scorched gold by the sun turning imperceptibly across the night, not falling, not fleeing, but aligning. Every second its new heading carved deeper into the plane of Earth's orbit, a perfect arc drawn in silence. By the time the global press caught a hint of the anomaly, the phrase Delta V in the impossible direction had already entered classified memos. It meant one thing: Atlas was not drifting anymore. It was steering. By the final week of December, the deviation was no longer theory. Tracking stations from Canary Islands, Hawaii and Paranal confirmed that 3I Atlas had executed a measurable shift toward the Earth's orbital corridor. It was not an impact course, not yet, but the geometry was precise enough to earn a codename inside the International Asteroid Warning Network, the Earth Exists report. The name sounded cryptic, as though the object had simply acknowledged us. The update arrived quietly in the JPL database position. Discrepancy 15 arc minutes east of prediction, translating to more than 1 million kilometers of lateral displacement. The direction of travel was impossible, a sideways drift perpendicular to the pull of the sun. The calculation demanded a velocity change of nearly 4 kilometers per second, the same figure already haunting the Delta V reports. For a time, no one wanted to publish. Emails circulated in euphemisms, trajectory refinement, extended monitoring, possible correlation. The official statement to the press was a single sentence: no immediate threat has been identified. Unofficially, the tone was different. Teams began running worst-case simulations. If the drift continued, Atlas would pass through Earth's gravitational influence by late January. Inside the Planetary Defense Coordination Office, engineers double-checked every constant, every sensor calibration, but the result held. The object's orbit was no longer passive. It had selected a path. You can imagine the unease in those rooms, the quiet realization that this was not a comet behaving badly, but a system expressing choice. The Earth Exists report became shorthand among analysts for a single idea: it knows we're here. By the time the data reached the United Nations Space Situational Awareness Desk, all language had softened again. The official phrasing increased observation recommended. But between those lines, everyone could read the truth: an interstellar object had turned toward us, not in collision, but in attention. And as the year ended, the world waited for January's sky to clear, wondering if the next coordinates would bring confirmation or contact. By the last days of December, the numbers stopped arguing. Each new solution pointed the same way: 3I Atlas had shifted again, not by accident, but with the steadiness of intent. What began as a discrepancy became a rhythm, and with that rhythm, the work changed from discovery to vigilance. They named the effort the IAWN Monitoring Initiative, the first coordinated planetary defense campaign aimed at a visitor from beyond the sun. The International Asteroid Warning Network, built to watch for impact threats and drifting debris, retuned its global lattice to a single silent point. On November 27, 2025, the campaign opened. It would run through January 27, 2026. Telescopes took their turns like a relay. Pan-stars combed the pre-dawn over Hawaii. Lucia and Paranal swept Chilean skies at dusk. Mount Lemmon and Kitt Peak filled the gaps over North America. Far above the weather, Gaia traced the same star field from orbit. Every station extracted the same set of measures position against background stars, brightness curve, polarization, angle, tiny changes in reflectivity. All streams converged at the IAWN Secretariat near Vienna, where analysts layered time on time until a picture of stillness emerged. You can place yourself in one of those control rooms. The air is cold, the fans blow the light from the monitors the only day. Frame after frame, the object returns as a single pale pixel holding a perfect line. No flares, no jets, no measurable non-gravitational push. The curve of light is so smooth it feels deliberate, as if the thing is aware of its balance and prefers not to disturb it. Internal summaries adopted the most careful words available. They described behavior consistent with self-stabilization and recommended continuous tracking. Public notes sounded calmer still, labeling Atlas stable and non-threatening at its current trajectory. The language soothed, but everyone who watched the raw frames felt the same. Undertow stability was not the absence of motion. It was motion under control. Across the network, a quiet nickname spread for the object they could not provoke into drifting. People began to call it the breathing stone, not because it moved, but because its refusal to move pulsed like a slow heartbeat through the data. Every 12 hours, the lattice reported reacquisition. Every 12 hours, the numbers returned unchanged. And in that sameness, a pattern grew. The campaign had not only followed an object, it had met a response. We stand with them eyes on the same strip of sky. The world outside is loud, but inside the dome the only sound is the rhythm of a machine waiting for the next exposure. Atlas does not brighten to please us. It does not dim to hide. It holds, and from this point the mission narrows. 6 months of tracking astrometry spectra, light curve drift folded into a single geometry. What had looked like noise resolved into pattern. Inside the International Asteroid Warning Network, analysts gave that pattern a quiet name, meant only for internal notes, the 8 unlikelihoods, an homage to Avi Loeb's idea that too many improbable anomalies should not coexist in one object. First velocity about 58 kilometers per second relative to the Sun. Second eccentricity greater than 6, confirming an interstellar path. Third composition carbon dioxide where water vapor should dominate. Fourth, polarization extreme and negative dust scattering backward instead of forward. Fifth, the anti-tail, a jet aligned toward the Sun against the solar wind. Sixth, silent thrust substantial venting with no measurable non-gravitational acceleration. Seventh, the lateral shift, a change in velocity of about 4 kilometers per second, precise and sustained. Eighth, direction entry within roughly 9 degrees of the 1977 WOW signal region in Sagittarius. Taken one by one, each point invites an excuse instrument, bias viewing geometry, solar wind asymmetry. Taken together, they read less like a list and more like a sentence. The probability collapses into meaning. In the iron control rooms, the screens told the same story without words. 8 columns, 8 steady contradictions that refuse to be corrected. The hum of servers, the soft tick of time, stamps the same coordinates returning with the same defiance. No flare, no torque, no drift that could carry the blame. A new phrase circulated through internal summaries controlled revelation. Perhaps the object was not concealing anything. Perhaps it was disclosing itself by degrees motion, as grammar chemistry, as emphasis silence, as punctuation. Some called it coincidence. Others more cautiously called it communication written in physics. After the 8 unlikelihoods were defined, the language of science changed tone. Anomaly became risk, and risk became protocol. Across the network, the silence of 3i Atlas was translated into a word that appeared in every report: preparedness. It sounded neutral, but behind it was a different pulse, an admission that something unknown could no longer be ignored. Observatories continued to track, yet the data no longer drifted. The brightness curve flattened. The Delta V report stabilized. The JPL Horizons feed showed no new correction. It was the kind of stillness that makes machines hum louder, as if the noise must fill the absence of movement. The International Asteroid Warning Network extended its campaign without announcement. Every 12 hours, a new stream of photometric data was uploaded, compressed, encrypted. Transmission delays grew deliberate, not accidental. For the first time, planetary defense had entered a phase of observation that resembled contemplation. In Vienna, where the central node processed incoming frames, analysts began marking their logs not by event but by non-event. Atlas unchanged, brightness constant, trajectory nominal. Each confirmation deepened the unease stability, repeating like a mantra. Preparedness became rhythm, an act of maintenance, a ritual made of numbers. Imagine reading those lines of telemetry night after night. You no longer search for motion, you study stillness. You start to sense that prediction is no longer useful because the object is no longer behaving like a body. Within the Planetary Defense Coordination Office, simulations multiplied. Gravitational models impact trajectories, thermal dispersions. Each one ended the same way: no deviation, no threat, no answer. In this absence, fear evolved into procedure. And while official statements repeated the words stable and non-threatening, the tone grew quieter with each release. Preparedness had become performance, an attempt to reassure a world that was not watching closely enough to be afraid. The truth was simpler. The object had stopped moving. The systems built to predict motion were left predicting themselves. And somewhere between data and faith, humanity entered its first rehearsal for contact not with a signal, but with a silence that seemed to think. By the beginning of December, silence had become the new signal. 3i Atlas was gone, lost behind the Sun, in the phase astronomers call the blind window. During this interval, the object passes so close to the solar disk that every observation fails. Light curves, flatten, sensors saturate, and what remains is the hum of a system waiting. For 22 days, the world's most advanced telescope stared into brilliance and found only absence. The solar and heliospheric observatory positioned between Earth and the Sun adjusted its field of view to the coordinates where Atlas should have been. In its LASCO C3 camera, a brief flare crossed the frame, one line of static, one possibility. Some called it noise, others marked it as the faintest whisper of motion. Inside the International Asteroid Warning Network, the algorithm flagged the event possible reacquisition. It was not proof, just a pulse inside the glare, but after weeks of emptiness, even coincidence felt like return. When comets pass perihelion, they either fragment or emerge transformed. Yet Atlas had already rewritten expectations. It did not accelerate when venting, did not dim when cooling, and did not bend under solar pressure. To vanish completely felt in a way like continuation, a pattern extending into invisibility. Scientists began calling the interval the December window. The term carried two meanings: a literal loss of visibility and a figurative pause in certainty. In laboratories and control rooms, the data streams became monotones of white. Instruments designed for measurement now produced meditation. The deep space network received only saturated frequencies. No Doppler shifts, no sideband artifacts, no drift. The absence itself became measurable: 22 days of immaculate silence. Some within a yen suggested that Atlas was not gone at all, only hidden by excess. In the fierce brightness of the corona, it could have been changing, sublimating its outer ice, adjusting orientation, shedding material for reasons unknown. Such speculation remained outside the official summaries, yet it lingered in footnotes, where science often keeps its doubts. And so December turned. The sun began its slow departure eastward, exposing once again the region of sky where Atlas should reappear. Telescopes aligned, CCD arrays cooled. The first frames came in empty, flawless absolute. When January light returned, the silence ended in data, not words. 3i Atlas should have reappeared, its coordinates predicted to within seconds of arc, but the telescopes found nothing. No tail, no nucleus, no residual cloud of dust. The absence itself became the new discovery. And in that vacuum, another kind of signal began to move conversation. Across observatories, the term controlled revelation resurfaced. It had been a whisper in the EON logs months earlier, a speculation that the object might reveal itself in deliberate phases. Now, it turned into a cultural riddle. What if the next revelation wasn't astronomical at all? What if it was political? In early press releases, NASA, ESA, and UNUSA maintained calm. The official tone was identical across agencies. 3i Atlas remained stable and non-threatening. No mention of its disappearance, no update on its current position, no image. The Minor Planet Center showed no revision to its last known orbit. The data froze, but the language continued polished and uniform. Within scientific circles, two schools formed. One favored disclosure, the belief that transparency would preserve credibility. The other insisted on denial by omission, the idea that silence was the safest form of communication. Both sides agreed on one thing: something unprecedented had occurred. Atlas had performed every impossibility, and then removed itself from observation without trace. In private channels, leaks began surfacing. Mentions of spectral interference, telemetry inconsistencies, transient noise near the Deep Space Network's Madrid antenna. Each fragment small, unverifiable, tantalizing. The story spread through physics departments like a rumor of faith. Imagine watching it unfold the way institutions protect what they cannot define. The press briefings that sound like echoes of one another. The comforting repetition of words like nominal, stable, ongoing, each chosen to seal uncertainty beneath a calm surface. There were those who believed the agencies had already seen enough images, perhaps of something mechanical, geometric, too deliberate to release. Others believed the silence was not deception, but preparation that disclosure, if it came, would not arrive through a microphone but through the object itself. The world was not told that the ION servers recorded a final pulse on the last day of the December window, an alignment of photometric noise that matched the frequency of the 1977 WOW signal. The reading was dismissed as interference, yet the timestamp matched the moment Atlas should have emerged from behind the sun. After the argument over disclosure and denial, a deeper quiet began. 3i Atlas had not returned. No brightness curve, no radio reflection, no cometary trail across the heliospheric monitors. The last valid ephemeris expired mid-January. By February, even prediction was an act of memory. The International Asteroid Warning Network marked the end of its campaign at 0304 UTC observation, suspended until reacquisition becomes possible. The phrase repeated through every transmission hub Vienna, Pasadena, Canberra, the same words in different time zones carried by systems built to wait. At the Jet Propulsion Laboratory, orbital solvers were left running unattended. The final integration produced an ellipse without closure. Its confidence interval expanded beyond the heliopause. The Deep Space Network reported perfect silence at the assigned coordinates, a flat baseline across all receivers as if the void had been polished. Engineers ran diagnostics twice. The result did not change. Even the absence had become stable. Elsewhere, the habit of looking persisted. Rubin Observatory swept the ecliptic for residual fragments. Euclid imaged near-infrared fields towards Sagittarius A. The square-kilometre array pathfinder mapped hydrogen line noise across the region, once associated with the WOW signal. No anomalies appeared. Still, each dataset was archived, checked, rechecked, as if confirmation could exist without discovery. When analysis reached exhaustion, pattern seeking became philosophy. Teams began to compare dark frames, noise, histograms, entropy ratios, spectral persistence. Nothing correlated. Yet the act of searching had changed shape. Procedure became meditation. What began as preparedness had evolved into endurance, and endurance into identity. It was within those final internal notes that a new term appeared, the waiting species. It described neither optimism nor failure, but a conditioned awareness extended beyond evidence. A recognition that humanity's instruments, like its thoughts, are designed to keep turning even after the signal stops. Planetary defense protocols were quietly updated. A new section, Post-Event Vigilance, instructed all observatories to maintain minimal monitoring of defunct coordinates. The reasoning was technical, the effect was devotional. The sky had become a laboratory for patience. Night after night, telescopes returned to the same coordinates, measuring stillness with increasing precision. Algorithms refined the silence into more symmetrical forms of silence. Servers archived terabytes of nothing, and through it all a species waited, watching not for light but for recurrence. By late February, no catalogue listed Atlas as active, yet every system still aligned toward its ghost coordinates. The search continued, not to find the object but to preserve the motion of attention itself, the single human reflex the universe had quietly answered with its own stillness. By March, the campaign files were archived. 3i Atlas designation 3i 2025 A1 no longer occupied any catalogue. The servers at the International Asteroid Warning Network entered standby. The Jet Propulsion Laboratory cleared its orbital cache. Only metadata remained, numbers without coordinates, coordinates without body. The object had not ended, it had exceeded definition. The James Webb Space Telescope searched the predicted emergence corridor and found nothing but background infrared noise. The Deep Space Network listened across the hydrogen line and returned perfect silence, no echo, no scatter, no modulation. A kind of mathematical zero filled the spectrum and equilibrium between everything known and everything assumed. To the systems built for certainty, that stillness became unbearable. Every algorithm tried to make pattern from nothing: gravitational residuals, isotropic bias, even cosmic microwave fluctuations. None produced motion. The more the models improved, the more absolute the absence appeared. Observation itself had turned inward. Then came the final memo within the IA Datuan archive. Its title was Procedural Termination of Continuous Monitoring Protocol. But the closing line read differently. No further action required. Continue listening. No signature. No timestamp. The origin field was blank, as if the system itself had generated the instruction, an echo written by the act of observation. The term controlled revelation survived in scientific shorthand. It no longer referred to Atlas directly, but to the behavior of knowledge under uncertainty. How much a civilization can see before it must stop, how much silence it can translate before mistaking it for intent. In this sense, Atlas had succeeded not as an anomaly, but as a test, a measure of how far attention could stretch before it became faith. The Rubin Observatory still sweeps the ecliptic. Euclid continues to map the faint light near Sagittarius A. The square-kilometre array calibrates its antennas on the same frequency that once held the WOW signal. All of it, Observation, calibration, repetition is a ritual made of science, a way to remain synchronized with what might return. We do not know if 3I Atlas disintegrated, transformed, or departed. The equations hold 3 possibilities and reject none. Perhaps the object was a relic of an ancient disk older than the galaxy itself. Perhaps it was a fragment of engineering lost between stars. Or perhaps it was only coincidence, the universe briefly arranging chaos into something that looked like intention. What remains is the practice to measure, to interpret, to wait. The waiting species continues its work, refining silence into finer resolution. Each telescope that opens to the night sky extends the same gesture, the same question that brought Atlas into focus and then into mystery. The signal never repeated. The orbit never returned. Yet the silence it left behind still moves through every array, every observation log, every moment of stillness between data points. The story of 3I Atlas does not end with discovery or loss. It ends here with a civilization that keeps listening and a universe that in its own perfect symmetry listens back.